What is energy? Energy is defined as the ability or capacity or capability to do work. I need energy to build muscle. Now, some books will say it is the ability, some will say capacity, others will say capability. Whatever you say does not really matter, provided you understand the fact that energy is needed for work to be done. That means energy is a prerequisite for work to be done. It's a requirement, it's a necessity. It is the major necessity for work to be done. If there is no energy, there will be no force. If there is no force, the object will not cover a particular distance for we to not see there is work done, or for us to assume there is work done. Now, there are different forms of energy. All right. Now, some persons will tell you there are 10 forms. Some will tell you there are 5 forms, or tell you there are 6 forms. In actual fact, there are 6 true forms of energy. There is mechanical energy, there is electrical energy, there is chemical energy, there is heat energy, light energy, and of course sound energy. These are the 6 true forms of energy. Now, mechanical energy is divided into 2 categories. That is potential energy and kinetic energy. Potential energy is the energy possessed by a body by virtue of its position. By virtue of its position. While kinetic is the energy possessed by a body by virtue of its motion. The formula for potential energy is given as mgh, while for kinetic energy it is given as half mv square. For potential energy, mgh, kinetic, half mv square. Let's show derivation of this formula. Let's show how potential energy was got as mgh and kinetic was got as half mv square. Recall that from work we said W is equal to F times S. Recall I also told you that F can be given as mg, right? That was the second formula I gave to you when we discussed work. If F is equal to mg, we can therefore say work is equal to, in place of F, we can say mg times x, right? S in this case means displacement. Whenever displacement is in a vertical form, we can then say it is height. So if I change this S to h, this becomes W equal to mgh, which is the formula for potential energy. So this right here is the formula for potential energy. This is the reason why the unit of work and the unit of energy is the same, which is joule. Well, I've not showed you that of kinetic energy, but now from potential energy, from what I've shown now, it is very, very clear that the unit of work and unit of potential energy should be the same, which is joule, as shown. The next part now is kinetic energy. Q dot E. We're going to use the same method we use here in the case of work. So come out and say work is F times X. This time around, we can decide to use the very first formula I told you about in work. If you've not watched work, watch the video of work. Alright, watch the video of work in this channel. Now, from what we said about work, we said F is equal to MA, right? If F is MA, we can say W is equal to MAX. Remember, we also said something about S. S has different formulas. One of such formulas is V squared over 2A. So I can come back and say W is equal to, in place of M, alright, M, in place of A, alright, A, in place of X now, is now V squared over 2A. So I'll say V squared over 2A. That means work is equal to MAV squared over 2A, right? This A can cancel this A. So that work is now equal to mv squared over 2, which is the same thing as saying half mv squared, which is equal to the formula for kinetic energy. So I've just shown to you the reason why work, potential energy, and kinetic energy have the same units. They have the same unit because potential energy and kinetic energy were both derived from work, meaning you need energy to do work, and whenever you do work, it is because there is energy, or there was energy. The next part now is energy interconversion. Energy interconversion. So on this aspect, we're talking about different appliances and the energy interconversion they carry. So I'll give you some. Electric bell, for example. The energy conversion for electric bell as the name implies, it is electric then to sound. That's for electric bell. For pressing iron, can you guess this now? Pressing iron, of course, all pressing iron, or most of them actually are electrical pressing iron. So it's from electric to heat. All right. There are others as well. There is bulb, electric bulb. In this case, we have electric to light. There is also generator. There is also generator. In the case of generator, we have mechanical to electric. Please do not make mistake to think for generator it is chemical because you use fuel. No, the fuel used in generator is used to move the motor, which is mechanical energy, and of course which generates electric energy. We'll start discussing electromagnetism and we'll explain this. Then for loudspeaker and microphone. Now I like to teach both together so you don't confuse this in exam or you don't mix it up in exam. For microphone, if there's a microphone, for example, you talk, how are you doing? That is sound energy from your mouth first, then electric energy. So for microphone, it is sound to electric. Sound to electric. While the speaker, you can't see the person, or you will not be able to see whoever is talking on the speaker, right? But you hear the sound. And all speakers are electric devices. So for speaker, it is electric to sound. Meaning from microphone to speaker, what you have is sound to electric, then back to sound. Alright, very important. Now, for pressing iron, you need electric to heat. You see that already. You might be tempted to say that it's not just electric to heat, it's electric to light and heat because there's a little bulb on the pressing iron. Please do not say that it's electric to heat because heat in this case is what we need. That's why we call it pressing iron. For electric bulb, it is electric to light because you need the light. The reason why I can see me now is because of the light from the electric bulb. Alright. If, however, the electric bulb is placed in an incubator where the light is not really what we need, what we actually need is the heat from the bulb. In that case, we can now say electric to heat because that's an incubator, we need the heat. But for normal bulb that we need to see is electric to light. Alright, so solve some questions, or we'll solve some questions with regards to what I've said so far. So that is all about energy. As I said earlier, energy is not difficult. There's really nothing here. All you need to understand is the formula for electric energy, formula for potential energy, the force of energy, definition of energy, and the interconversions. That is all you need to know for energy, and of course the units. That's all you need to know for energy, and you are good to go. Alright, so that is it. Like, share, subscribe, and I'll see you in the next video.